Now we're going to do operations on radicals. And basically, when in your whole career, math career, you learned so far that there are 4 math operations: addition, subtraction, multiplication, and division. Everything else that you learn in math is just some form of those things. You've learned about exponents, but you learn that exponents are just an extension of multiplication. It means you're multiplying things together to get larger and larger numbers. So basically everything can be done with those 4 math operations. So we're going to now talk about how to add, subtract, multiply, and divide radicals. And some things are a little bit different with radicals than you might think. For example, if I have something like the square root of 3 plus the square root of 2, there is nothing I can do there. That would be my answer for that expression, because unless I have the exact same thing underneath the radical sign, they are not alike and I can't add them together. I'm just not allowed to do that. Now, if I were to have something like the square root of 3 plus the square root of 3, that could be added, but it might be a little different than what you think. A common mistake is for kids to put the square root of 6, but that's completely wrong. You're going to treat this kind of like you treated like terms back when you did algebra. Like, for example, if I had 2x plus 4y plus 2y plus 8x. Well, if I were to do that problem, I have to pay attention to the things that are alike, the things that have like terms. So the 2x and the 8x are alike. 2x plus 8x is 10x, and 4y plus 2y is 6y. So my answer there would be 10x plus 6y. I learned in Algebra 1 that I can't go any further than that. I have 10 x's and 6 y's, but since they are not alike, I can't combine them. It's kind of like saying if I have 10 apples plus 6 bananas, that doesn't give me 16 apple bananas. There's no such thing. I still have 10 apples and 6 bananas. I can't combine those two things to make one thing. And this is very similar. Whatever is underneath the square root has to go together. Okay, so basically what I have here is 1 square root of 3 plus 1 square root of 3. Since I have 1 here and 1 here, they're understood to have 1 in front, kind of like x plus x is 1x plus 1x equals 2x, okay? Since I have 1 square root of 3 plus 1 square root of 3, I end up with 2 square root of 3. And that's a little bit different. It's a little unusual the way it looks. But once you get used to it, it's not too bad. Back up to this problem. Since they are not alike, I can't add them together. There's nothing else I can do for that. So you need to consider what happens if I have a radical plus a radical and those radicals can be simplified before I add them together. That's what I would need to do. I would simplify the radicals individually and then combine the terms together if I can. So let's talk about what happens when we have radicals that haven't been simplified that are supposed to be added together. Looking at this at the beginning, there's nothing I can do here. They are different numbers underneath the radical, so I cannot add those together until after I've simplified them. And then the only way I'm allowed to add them together is if what's underneath the radical, what's left underneath, is the same number. Then I can treat them as like terms. Otherwise, I won't be able to do anything else. So we're going to break this down just like we learned in the last section. We're going to break them down, simplify each individual problem separately, and then go from there. Okay, so 54. If I think about 54, that is 9 times 6. And then 9 would be 3 times 3. 6 is 3 times 2. So anything that shows up twice, I can bring it out once. So my 3 shows up twice. I can bring out a 3. The rest of them only show up once. So that's 3 square root of 6 for the first part. And then for the 24, if I break that down, that's 4 times 6. 4 is 2 times 2. 6 again is 3 times 2. So that means I can bring out the 2. And then I have square root of 6 left underneath. And then that plus sign just comes down. Now, what I have, what's left, is 3 square root of 6 plus 2 square root of 6. They do have the same thing underneath the radical, so I'm allowed to add those together. So 3 plus 2 is 5, and that will be 5 square root of 6. Now be careful, don't add the 6's together. That's sort of like your variable per se. Like when if we had 3x plus 2x, it would be 5x, okay? So you do not add what's underneath the radical. In fact, that is not allowed. You can never add radicals together what's underneath. For example, again, and this is the second time I've said this, square root of 3 plus square root of 2. That is not the square root of 5. You cannot do anything with that. That expression is already simplified. The next one is similar, but instead of square roots, we have cube roots here. So I'll break it down the same way. I can bring out a 4. If I do that, that's 32. That 4 can be brought down to 2 and 2. 32 is 16 and 2. That 16 is 4 and 4. And then each of those can be broken down into 2's. Notice the index number is 3, so it has to show up 3 times to be brought out once. So anything that shows up 3 times, I can bring it out 1 time. So let's see, I've got 1, 2, and another 2, and that last 2 stays, inside. And then if I break down this one, cube root of 16, well 16 is 4 and 4. I can break that down into 2's. So anything that shows up 3 times can be brought out once. So that's going to be 2 cube root of 2. I keep the minus. And so this is 4 cube root of 2 minus 2 cube root of 2, and 4 minus 2, they're like terms, so 4 minus 2 is 2, cube root of 2 for my answer there. This one has 3 terms instead of 2. We're going to do it the same way. The square root of 72, if I break that down, that's 2 times 36. 36 is 6 times 6. So I can bring a 6 out. Anything that shows up twice can be brought out. Square root of 2 is left inside. It is okay to bring things out like this. This does not have to be simplified completely to be able to bring it out. As long as you have something show up twice, you can bring it out immediately. You don't have to go all the way down, expand it all the way down. For this one, that is 6. So that's plus 6. And for this one, that's minus 8 is 2 and 4. So we can bring out a 2, and we have square root of 2. So we have 2 terms that are like. So 6 square root of 2 minus 2 square root of 2 is 4 square root of 2. And that plus 6 just has to be brought down. Now you could write that as 6 plus 4 square root of 2 or 4 square root of 2 plus 6. We cannot say that that's 10 square root of 2. That's completely wrong. The only way we could add those together is if they both have that square root of 2 attached. Okay, so that would be the answer to my problem. I cannot do anything else with that expression. Square root of 27, that is 3 times 9, and the 9 is 3 times 3. So I can bring out a 3. I've got the square root of 3 left inside. Minus 75 is 3 times 25. 25 is 5 and 5, so I can bring out the 5. That's 5 square root of 3. And then here, for 48, that's 4 and 12. And then 12 is 4 and 3. So look, I've got a 4. I don't have to break it down all the way. I can bring a 4 out. So that's plus 4 square root of 3. And look what we've got here. All 3 of them are like terms, so that's nice. 3 minus 5 is negative 2. Plus 4 is 2. So the answer to that is 2 square root of 3. Okay, we've talked about adding and subtracting radicals. Now let's talk about multiplication of radicals. We are allowed to multiply anything. They do not have to be like terms to be able to multiply radicals together. All we have to make sure of is that the index number is the same. For example, if I had the cube root of 2 times the square root of 5, there's nothing I can do there. Not until I learn about rational exponents, okay? There is nothing I can do with this until I'm allowed to change the exponents to fractions and solve that way. So with a problem like this, as long as the index numbers are the same, in other words, they're both square roots, they're both cube roots, they're both fourth roots, whatever the index number is, it can be done. So with this, the square root of 3 times the square root of 2, we are allowed to multiply 3 times 2. So that would be the square root of 6. Okay? And then if that can be broken down any, we would break it down. But that one, there's nothing else we can do. So square root of 6 would be our answer. So remember, you're allowed to multiply anything you want as long as the indexes are the same. For this one, the square root of 10 times the square root of 2. Now, I could break them down first and then combine them, or I can combine them and then break them down. Depending on what you choose to do is up to you. Sometimes, like for this one, there's nothing you can do first, so you're going to have to combine them and then break it down. But sometimes you could break it down first. I tend to multiply them together first and then break down the final, because sometimes that creates less work. It just depends on your preference though. So for this one, square root of 10 times square root of 2, that would be the square root of 20. And at this point then I would break that down. 20 is 4 times 5, and then the 4 is 2 times 2, so that would be 2 square root of 5 as my final answer. Okay? It is not okay to just leave it square root of 20. In order for it to be simplified, it has to be in simplified radical form, and that means if there's anything underneath the radical that can be brought out, it has to be brought out in order to be in simplified radical form. Okay, for this one, I've got the square root of 36 times the square root of 5. Well, the square root of 36 is 6. And if I multiply that by the square root of 5, that's just 6 square root of 5. So that one's easier to break down first and then combine. For this one, it might be easier, and if you look ahead, sometimes it's a little bit easier to see. 8 times 2 is 16, so that's the same thing as the square root of 16, which is 4. For these, here, they've already been broken down, okay? And that's okay. If they've already been broken down, we then can multiply them together. So what you would do for a problem like this, it's really simple. We would multiply the outside numbers, so 4 times 2 is 8. Then we would multiply the inside numbers. 5 times 10 is 50. Then we have to look at what's underneath and simplify it if it will simplify. And the 50 can be broken down into 25 and 2, and 25 is 5 and 5. So that means I can bring out a 5. So 5 times the 8 that's already on the outside is 40. And then left inside is that leftover. See, that showed up twice. So I've got that leftover 2 inside. So the answer there is 40 square root of 2. Looking at this one, nothing can be done to the 8 square root of 3. 27 is 9 times 3. I can bring a 3 out. So for that, I've got 3 square root of 3. And here I've got 8 square root of 3. So this one I think is a little easier to break it down first and then multiply the two together. Then I'm going to multiply. 8 times 3 is 24. Square root of 3 times square root of 3 is square root of 9. Square root of 9 is 3. So that's 24 times 3, which is 72. And you can use your calculator to help you with the math. If you can't do it in your head, that's not a big deal. But the important thing is showing the work, understanding each step, and then getting your final answer. I do want to stress again the importance of making sure you're taking notes, making sure that you're showing your work. There are calculators that will do all of this for you, but using a calculator to do all this stuff is only going to set you up to really struggle later. So you've got to learn these basic skills, because when we get into imaginary numbers, there is no calculator that will do those for you. You have to know the skills. And we tend to learn those skills with easy problems like this, and then incorporate these these skills into the more difficult problems. So make sure you're not relying on a calculator to do these simplifications for you. It will just hurt you in the long run. All right, looking at this one. You're going to use your rules for algebra to solve this. And in algebra, we talked about the distributive property. anytime you have expressions inside a parenthesis with something multiplied by that parenthesis on the outside, we can take what's on the outside and distribute it. So that's what we're going to do here. So I'm going to go ahead and multiply. Remember, we can multiply anything. So square root of 15 times square root of 3 is square root of 45. Square root of 15 times square root of 5 is square root of 75. And then we're just going to bring down that minus square root of 27. Next, I'm going to simplify each of the terms individually. So 45, let's see, 45 is 9 times 5. Now I'm going to simplify a little bit differently just to show you how you can save some steps. 9 is a square number. What's the square root of 9? 3. That's what would be on the outside. So that's 3 square root of 5. And if you can do it that way, go ahead and save yourself some time. Because remember, we're trying to work more efficiently as we learn more and more about Algebra 2. It's the efficiency of doing this that's important. Square root of 75, well, 75 is 3 times 25. 25 is a square number. I can bring out a 5. So that's 5 square root of 3. For 27, I'm going to go ahead and put my minus. 27 is 3 times 9. 9 is a square number. I can bring out the 3, and the square root of 3 is left inside. So now I'm going to combine like terms. 3 square root of 5 doesn't have any like terms, so that just comes down as part of my answer. And then 5 square root of 3 minus 3 square root of 3 is a positive 2 square root of 3. I can't do anything else. That expression would be my answer. These are not like terms, so I have to leave it like that. It's okay to have several expressions within your answer and it still be simplified. Last one here, the cube root of 5 times the cube root of 25 plus the cube root of 7. For this, they're cube roots, so I'm thinking about things that have to show up 3 times in order to bring them out. That, just like the last one, is a distributive property problem. So I'm going to distribute. The cube root of 5 times the cube root of 25 is the cube root of 125. The cube root of 5 times the cube root of 7 is the cube root of 35. And then I'm going to break it down and simplify as much as I can. The cube root of 25 is 5. The cube root of 35 is 5 times 7. It won't break down anymore. Nothing comes out. So that's going to come down as my answer. Understand, that is my answer. It is not the same thing as 5 cube root of 35. I cannot just put those two things together. 5 cube root of 35 means 5 times cube root of 35. 5 plus cube root of 35 has to have the plus in the middle. Next, we're going to talk about simplified radical form dealing with division, and then we're going to combine all these things together. Okay, so let's talk about simplified radical form when we're dealing with rationalizing the denominator, okay? In order for a radical to be in simplified radical form, there are several things you have to make sure you have. You have to have the radical simplified completely. In other words, there can't be anything inside that radical that could have come out. So if you have the square root of 8, it's not simplified until you take that 2 out and it becomes 2 square root of 2. The same thing with division. You have to understand there's one special rule with division, and that is if you have any radical on the denominator, that radical has to be taken care of. You cannot have any radicals on the denominator, period, in order to be in simplified radical form. So if you look at this, just like before, I said, if we have a fraction underneath, that thing can be simplified to square root of 8 over square root of 9, okay? And then we simplify anything that we can simplify. So square root of 8, now we've done square root of 8 several times, so hopefully by now you know that's 2 square root of 2. If you know the answer, don't worry about breaking it down. Just get the answer down as quick as you can. Again, we want to work efficiently. The square root of 9 is 3. Okay, now looking at that, I don't have anything underneath the radical that can be brought out, and I don't have any radicals on the denominator. So this thing, as long as there's nothing that can be come out of that, is in simplified form. So for that one, I'm okay. I can leave it like that. 2 and 3 will not simplify. Okay? Now, let's suppose I ended up with, and I'll just give you this as an example, 5, let's say square root of 2 over 10. Let's say that's what I ended up with after I had simplified. Well, if that's the case, anything that's not under the radical kind of goes together. So I can simplify 5/10. Isn't 5/10 1/2? So 5 goes into 10 twice. So that answer would now be square root of 2 over 2. So we simplify the fraction as much as we can. Okay? Now, what if I ended up with, or I started with, something like this, 2/4? Okay? If they're both underneath the radical, and that fraction can be simplified, then that is the same thing as the square root of 1/2. I'm allowed to simplify before I break it down. Okay? So that brings me to my next example. Okay? If I'm going to simplify that square root of 1 over 2, square root of 1/2. First thing I would do is break it down. Square root of 1 over the square root of 2. Now, hopefully you realize the square root of 1 is 1. Now, at first glance, people might think that that's finished, but it's not, because we're never allowed to have a denominator that has a radical in it. We have to eliminate all radicals from the denominator, and that's called rationalizing the denominator. So what I need to do is, if it's a square root, it's usually pretty simple to do. To get rid of a square root, I'm just going to multiply by the same square root that I had. But if I multiply the bottom by that square root, I have to do it on top as well, because we know that in order for this fraction to be equivalent to what I've got, or what I'm going to have, I have to multiply by 1. I can't multiply by something on the bottom unless I also do it on the top, because if I multiply that fraction by 1, my fraction doesn't change its value. So by multiplying this fraction by 1, or square root of 2 over square root of 2, I'm going to multiply straight across. I've got square root of 2 over, now think about this, square root of 2 times square root of 2, that's square root of 4. So basically that, since it's the square root of 4, is just going to be 2. Okay, now, a common mistake here is people look at that and they say, oh, well, that's just 1. They're both 2, so I can divide them, it's 1, square root of 1. No, you can't do that. This is the square root of 2, and this is 2. They're very different. So since one's under the radical and the other one is not, there's nothing we can do with that. We either simplify both things from under the radical or both things not under the radical. We can't simplify something that has one or the other, okay? So that is simplified radical form. I have rationalized the denominator. I've gotten rid of that square root on the bottom. All right, so let's look at another one. Here I have 5 over square root of 3. I can't have any radicals on the denominator, so I'm going to multiply by that radical to get rid of it on the top. So when I multiply these together, remember that's just 5 square root of 3. We did that earlier in the section. And then square root of 3 times square root of 3 is just 3. Remember, I cannot simplify those because one's under the radical, one is not. This is my answer. And then the last one in this little section here, I've got 2 over square root of 8. Now there's a bunch of different ways I can do this one. But I tend to like to simplify first when I'm dealing with radicals within a fraction. So I'm going to go ahead, I know that 8 is 2 square root of 2. So I'm going to go ahead and do that. And then if you look at what you have here, these 2's will cancel because neither one of them is under a radical. They will both cancel out. So I end up with 1 over the square root of 2. And then I'm going to multiply by the square root of 2 on the top and bottom, leaving me with the square root of 2 over 2. Okay? So that is rationalizing the denominator. Let's do a few more examples, and then we'll get into rationalizing denominators with something other than a square root. All right, so let's look at this one. I'm going to simplify first. I think that's a little bit easier. I know 2 goes into 4, so I can simplify that That leaves me with a 2 on the top, on the numerator, and the square root of 5 on the bottom. Then I can't have any radicals on the denominator, so I'm going to have to multiply by the square root of 5 on the top and on the bottom. When I do that, remember up top, that would be a 2 times the square root of 30. And square root of 5 times square root of 5 is just 5. Now, square root of 30 is, let's see, that is 2 times 3 times 5. So there's really nothing I can bring out of that one. The 2 and the 5 will not simplify, so that would be my final answer. Okay, this looks a little different. Whenever you have a whole number in front of something that has a fraction, remember, whole numbers can be written as fractions. So that 2 is the same thing as 2 over 1 times the square root of 1 over the square root of 3. You can go ahead and combine those things together. Just understand that the number in front goes on the top. It's part of the numerator because it's 2 over 1. So when I simplify this, that's 2 times 1, which is 2, over 1 times square root of 3 is just square root of 3. Now it's pretty simple. Now, if you could go straight from here to here, I'm fine with that. That's not a problem. Again, we want to work more efficiently. So for this, I'm going to multiply by square root of 3 on the top and the bottom. So I have 2 square root of 3 over 3. And if it will simplify, I would simplify, but nothing simplifies here. So that's all we can do. That would be my final answer. Okay, so what if you have radicals dealing with cube roots instead of square roots and you have fractions? We still have to rationalize the denominator. In other words, we still can't have any radicals in the denominator. And that's going to be throughout Algebra 2 and pre-calculus. You're not going to be allowed to have radicals in the denominator. Now, once we get into calculus, sometimes those answers are so complicated we don't want to have to rationalize the denominator because the algebra associated with that is so hard, it just takes away from the calculus that we're trying to learn. So for now, they're going to be easy enough to where we'll rationalize them all and you'll never leave them like that. So I'm going to first take the cube root of 5 over the cube root of 6. I separate it out. And then I'm going to try to break it down if I can. Now, cube root of 5, there's nothing that comes out of that, nothing that will break down. Cube root of 6 is 2 times 3. There's nothing that'll come out 3 times, so I can't really do anything with that. So my only step here is to rationalize the denominator. Now, how is this different from a square root? Well, we know that we need 3 6s to be able to bring a 6 out, not just 1 6, okay? So where if that were just square roots, like if that had been the square root of 5 over the square root of 6, I would have multiplied by the square root of 6 on the top and bottom and been able to get the answer pretty easily, okay? Well, this isn't a square root. I don't just need 1 more 6. I need how many more 6s? I need 2 more 6s because I need 3 total. So I'm not going to multiply this by the cube root of 6. I'm going to multiply it by the cube root of 6 times the cube root of 6, or the cube root of 36. Now, I still have to do it on the top and the bottom, not just the bottom, because I have to make it so that I'm multiplying it by 1. Now, if you think about this, the cube root of 6 times the cube root of 36, well, that's just going to be 6, because that's the cube root of 6 times the cube root of 6 times the cube root of 6. So that's just 6. And then on the top, I'm going to have the cube root of, and that's, let me see, 150 plus 30, 180. Okay, so that's the cube root of 180. Now, you could try to break that down, but if you do, it's just going to be 5 times 6 times 6, and those will both be 2 and 3, 2 and 3. So nothing comes out 3 times, so there's nothing that will simplify. So that is my final answer there. For this one, I'm going to break it down first. I've got the cube root of 8 over the cube root of 9. Now, keep in mind, I could multiply this thing by the cube root of 81 if I wanted to have 2 more 9s, or I could think 9 is already 3 times 3. So I have 2 3s, I just need 1 more. So for this one, that's a little bit easier to just multiply by the cube root of 3 to get my 3 3s, instead of multiplying by the cube root of 81 to get 3 9s. If I multiply by the cube root of 81, I'd still get the same answer, but I'd have more to simplify later. So it's easier to choose the smallest number you can to get your 3 numbers and move on from there. So up top I have cube root of 8 times cube root of 3, which is cube root of 24. And then on the bottom, that would just be a 3. Then I see if 24, if I can break that down, let's see, 24, that is 3 times 8, right? And then 8 is 2 times 2 times 2. So I can bring a 2 out. So that's 2 times the cube root of 3 over 3. If the 2 and 3 could simplify, I would simplify it, but in this case it doesn't, so that's all I can do. Okay, next we're going to do some examples that combine some of the different operations, okay? And this will combine your work in Algebra 1 with the new things that we are learning now in Algebra 2 with radicals. So if you look at this one right here, we've got the square root of x plus 5 times the square root of x minus 5. Now you've got a binomial times a binomial. Now hopefully you remember from Algebra 1, when you have 2 binomials multiplied together, we have to use FOIL to simplify that. So in other words, we take the first term, multiply it by both of the terms on the second side, and then the second term, multiply it by each of the terms on the right-hand side, and we'll be able to have our final answer once we combine the like terms. So I'm going to do that. All right, now let's think about it. The square root of x times the square root of x. Well, that's the square root of x squared, or just x. Okay. The square root of x times negative 5 is minus 5 square root of x. 5 times the square root of x is plus 5 square root of x. The sign in front goes with it. And then positive 5 times negative 5 is a minus 25. Okay, now look at the middle terms. Those are like terms. We've got a negative 5 plus, or negative 5 square root of x plus 5 square root of x. They cancel each other out, leaving us with 0. So we have x minus 25. That would be my final answer. Now, I want you to pay particular attention to what we ended up with here, what we started with here. And notice the middle terms cancel out. When you start with opposites, in other words, look at the first terms. That was the same. Look at the last terms. They were the same, right? The only thing different here is one of them is a plus, one of them is a minus. That is something called a conjugate. When you have a conjugate, when we multiply those 2 conjugate binomials together, the middle terms will always cancel out because they're always going to be the same, but opposites, okay? Now, that will only happen when both terms are the same, the first and last are the same, but the sign is different, okay? Now, look at what we've got here. Square root of 5 plus 1 squared. Well, if you think about your knowledge from algebra, the square root of 5 plus 1 squared means we write it down twice and then we FOIL. Now, are these conjugates? They are not, because one's plus and the other one is plus. They are not opposites, okay? Conjugates have opposite signs. So with this one, I'm going to do the same method. I'm going to use FOIL, but my answer is going to have 3 terms, or maybe even 4, depending on what I've got. So square root of 5 times square root of 5, that's the square root of 25, which is 5. Square root of 5 times 1 is square root of 5. 1 times square root of 5 is square root of 5, and then 1 times 1 is 1. And now I combine my like terms. So 5 plus 1 is 6. Square root of 5 plus square root of 5, remember, is 2 square root of 5. And that's my final answer. Looking at this one, I have a monomial times a binomial. For that, that's just the distributive property. So I'm going to multiply the term on the outside by each term on the inside. Well, 2 square root of 2 times square root of 2. Well, the 2 times 1 is 2. Square root of 2 times square root of 2 is 2. So that ends up being 4. And then 2 square root of 2 times 2 is 2 times 2 is 4. Square root of 2. Those are not like terms. That's all I can do. That would be my answer. All right, look at this one. Square root of 5 plus 1 over 2 times square root of 5 minus 1 over 2. Well, if it has a multiplication, I'm going to multiply straight across. Multiply the top together and then multiply the bottoms together. And then I would simplify what I have. Well, the bottoms are easy. 2 times 2 is just 4. So my answer on the bottom is going to be 4. On the top, I have two binomials. I have this binomial times this binomial. I have to use FOIL on top here. A lot of kids miss that. They miss the FOIL, so you got to be really careful. All right, square root of 5 times square root of 5 is 5. Square root of 5 times negative 1 is negative square root of 5. 1 times square root of 5 is square root of 5. 1 times negative 1 is minus 1. And then if we're combining the like terms, these are opposites. They cancel. 5 minus 1 is 4 over 4. And we end up with a final answer of 1. That one worked out pretty nice. Notice here, these two are added together. Really, the parentheses don't mean a thing. They're just there to confuse you. I could give you that, and you need to understand that it's the same thing as this. So I'm going to just combine my like terms. So 2 plus 2 is 4. Negative square root of 3 plus square root of 3 is 0. That cancels. So my answer there is just 4. For the next one, this is another FOIL problem. Notice they are conjugates. I have the same first terms, the same last terms, and they have different signs. So we know ahead of time that the middle terms are going to drop out. Okay? Now, so 2 square root of 5 times 2 square root of 5. Well, 2 times 2 is 4. Square root of 5 times square root of 5 is 5. So that gives you 20. 2 square root of 5 times negative 3 is negative 6 square root of 5. 3 times 2 square root of 5 is 6 square root of 5. And 3 times negative 3 is minus 9. And I combine my like terms. The middle terms cancel. 20 minus 9 is 11. So when we're dealing with radicals and we have conjugates, it turns out to be really nice, because if they're conjugates, we're going to end up with a nice whole number for our answer, which comes in handy when we have something like this. Because what we're going to have to do here is we're going to have to ask ourselves, what can I multiply the bottom by so that I end up with simplified radical form? Because remember, you're not allowed to have square roots on the bottom, okay? So I want you to consider what happens. The first time I usually show this to my students and I ask them what they think we should do, they say, well, we'll multiply by square root of 7 on the top and the bottom. And that's a common misconception. That's a common mistake. Because if you think about it, on the top, you would end up with square root of 7. But look what happens on the bottom. 3 times square root of 7 is 3 square root of 7. Square root of 7 times square root of 7 is 7. And we still have a radical on the bottom. So that doesn't work. It's not going to work to just multiply by the radical. What we have to multiply by is the conjugate, because a conjugate is going to get that thing down to a nice whole number. So let's try that again, and let's try working with the conjugate. So ask yourself, we have something with two terms here. What is the conjugate of that thing? We've seen conjugates now several times. The conjugate of 3 plus square root of 7 is just 3 minus square root of 7. Now keep in mind, in order to keep this equivalent, we have to multiply the top and bottom by the exact same thing, okay? We can't just multiply by square root of 7 because that doesn't get rid of the radicals, but we can't just multiply the bottom by the conjugate because then it's going to change the value of my original fraction. So I multiply the conjugate on the top and the bottom. Well, if I multiply 1 times that conjugate, I get the conjugate again. And then here I have to do FOIL. So 3 times 3 is 9. 3 times negative square root of 7 is negative 3 square root of 7. Square root of 7 times 3 is 3 square root of 7. Square root of 7 times square root of 7 is minus 7. Now, remember, if we're multiplying by the conjugate, every single time that conjugate is going to drop out our middle terms. Our middle terms are going to be the ones that contain the radical, which means our radicals end up dropping out. So on the top, I have 3 minus square root of 7. On the bottom, I have 2. If I can simplify, I would. Nothing simplifies there. So that's as far as I can go. Okay, so for this one, we again want to simplify this. We see that there are radicals on the denominator. So I'm going to have to simplify by multiplying by something that will make all the radicals disappear in the denominator. And we learned in the last example that the only way to get rid of both of the radicals is to multiply by the conjugate. So think about that. What is the conjugate? All right, I want you to pause the video and see if you can figure this one out on your own, and then we'll do it together. Okay, so hopefully you've had time now to do it. If I'm going to multiply this one by the conjugate, my conjugate would be square root of 5 plus square root of 2. So I'm going to multiply the top and the bottom by square root of 5 plus square root of 2. And the top by the same thing. I have to multiply by 1 in order to keep my fraction equivalent to what I started with. And then on the top, it's just a matter of doing the distributive property. So 3 square root of 5 plus 3 square root of 2. And then remember, on the bottom, the middle terms are going to cancel each other out. So if I think about that, square root of 5 times square root of 5 is 5. Square root of 5 times square root of 2 is square root of 10. Negative square root of 2 times square root of 5 is minus square root of 10. And negative square root of 2 times square root of 2 is a minus 2. And then notice my middle terms are opposites, so they do cancel. 5 minus 2 is 3. My numerator has 3 square root of 5 plus 3 square root of 2. And now pay attention to what you've got left here. I've got a 3. I've got a 3 in this term and a 3 in this term. So if you think about it, since all 3 terms have a 3, I could distribute that 1 3 out of the top. And then my 3's will cancel. I could cancel it like that by distributing, or I could notice they all 3 have them and cancel them out like that, leaving me with the square root of 5 plus the square root of 2 as my answer. Now remember, that's not the square root of 7. I can't add those together. That's all I can do for that problem. Okay, I have one last example for this section that kind of combines a lot of the different concepts that we've talked about in this section for simplifying radicals. Basically what I've got here is I've got 3 sets of radicals that are very different, and then they're each added or subtracted from each other. When I'm presented with a problem like this, what I'm going to do is I'm going to simplify each term separately. So I would take this term and simplify it, get it in simplified radical form, rationalize the denominator, do everything I can to each individual term separately, and then at the end combine the like terms together if I can, okay? So at this point, what I want you to do is pause the video, see if you can simplify each of these separately, and then we'll work together to try to find the final answer. So pause the video. Okay, so hopefully you've had time to finish the problem, or at least get started with it to see where you end up getting stuck maybe, and then we'll move on from there. If I'm going to solve each individual section separately, I'm going to just take this part and I'm going to do everything I can with it before I even worry about the other 2 parts. So think about what we learned with a problem like this. We said that if we have a number in front, that number is going to be placed on the top. like so, okay? Then, if I simplify the 27, remember 27 is 3 times 3 times 3. So I can bring out a 3, and I've got square root of 3 left inside. Now I need to simplify the denominator. I need to rationalize the denominator. I'm going to multiply by the square root of 3 on the top and bottom to do that. And then on the top, I have 4 times the square root of 3a. Remember, I'm allowed to multiply anything. And on the bottom, I have 3 times 3. 3 times 3 is 9. Now, if I could simplify the 4 and the 9, I would, but I can't in this case. I'm going to move on to the second part. In that one, if I simplify that or separate it out, I've got the square root of 4a over the square root of 3. Looking at that, I could bring a 2 out of there. 2 square root of a over square root of 3. And now I can rationalize my denominator. So that's square root of 3 times the square root of 3. So I've got 2 square root of 3a all over 3. I'm going to bring the plus down to put it in the middle. That's all I can do on that section. I'm going to move to this one. I've got that 2, it will be on top, 2 square root of a over square root of 12. Now, 12 can be broken down. I'll keep the 2 square root of a. 12 is 2 times 2 times 3, so I can bring a 2 out. So that's 2 square root of 3. Notice those 2's can be canceled out because they're the same. And then I need to rationalize the denominator. Square root of 3, square root of 3. So I've got square root of 3a all over 3. I'm going to bring down my minus sign. Okay, now, hopefully you know from your previous math experience that in order to be able to add fractions together, we have to have a common denominator. So in order to make these denominators the same, this one's a 9, that's a 3, and that's a 3. In order to make all of these 9s, I need to multiply the bottom and the top by 3 here, and the bottom and the top by 3 here. So that leaves me with 4 square root of 3a over 9 plus 6 square root of 3a over 9 minus 3 square root of 3a over 9. I keep the denominator and I add my like terms. So 4 square root of 3a plus 6 square root of 3a would be 10 square root of 3a. And then 10 square root of 3a minus 3 square root of 3a is 7 square root of 3a. If the 7 and the 9 would simplify, I would simplify them, but in this case they don't.